Plastic has been a defining material for our modern society, with its annual production reaching almost 370 million tonnes. Plastics combine high strength with a light weight and can be produced at low cost with limited use of energy or precious resources. However, the widespread use of plastic materials also generates huge volumes of plastic waste, 59% of which ends up in the landfill or environment, where it slowly degrades into microplastics and potentially toxic chemicals. Polyurethane is the sixth most important plastic material, with an annual worldwide production of around 20 million tonnes. Around 45% of end-of-life polyurethane is landfilled, which consumes valuable land resources and poses environmental hazards. The collection, proper processing and recycling of plastic waste is of critical importance to attain a sustainable society. Household plastic waste can be sorted by employing near-infrared sorting, rotary drums, and washing into separate fractions of high-density polyethylene, low-density polyethylene, polypropylene, and polystyrene. These plastic waste streams can be mechanically recycled to granulates for the production of non-food grade plastics, such as flower pots or shampoo bottles. Mechanical recycling results in lower quality plastics, also known as downcycling, and accounts for 12% of annual plastic waste. Polyvinyl chloride and polyamides are contaminants which cannot be mechanically recycled and thus require different recycling solutions. Almost 22% of polyurethane waste is mechanically downcycled, for example by the shredding and bonding of flexible polyurethane foam into gym mats and acoustic insulation. The introduction of dynamic covalent bonds in polyurethane foam is currently being investigated as part of the PUReSMART project, with the goal of achieving PU foam matrices that have enhanced intrinsic reprocessing and recycling properties. Incineration is the most common processing method, accounting for 25% of plastic waste and 33% of polyurethane waste. Incineration allows for the recovery of thermal energy, but also requires extensive scrubbing of exhaust gases and produces greenhouse gases. Dissolution and precipitation processes require the use of non-toxic and easily recoverable solvents to produce plastic granulates for product manufacturers and accounts for less than 1% of plastic waste. Pyrolysis involves the thermal decomposition of plastic at elevated temperatures in an inert atmosphere. The product mixture comprises a wide range of hydrocarbons requiring further processing by cracking. Pyrolysis can process mixed plastic waste streams, but is sensitive to PVC, PET and polyurethane impurities, and accounts for less than 1% of plastic waste. Finally, chemical recycling or CHEMOLYSIS requires the dissolution and depolymerization of polymers to constituent chemical materials for virgin-grade producers and accounts for less than 1% of the plastic waste. Well-sorted polyester and polyamides can be depolymerized into monomers by solvolysis, which can be employed to produce new polymers. An innovative process for the chemolysis of end-of-life polyurethane matrices is being developed as part of the PUReSMART project, with the goal of recycling the two main components, comprising the polyol and the isocyanate. Concurrently, an intelligent sorting process is being developed for separating the various polyurethane foams from end-of-life matrices.